Welcome to lab exercise 8, unix lab exercise 8. In this experiment, we have to perform process creation. So, three questions we have to do. So, first question, we have to write C or C++ program to create the following process hierarchy. Process A gets seconds, and then process B calculates hour, minutes, and seconds. So, now let's see how we can do. So, this is the program. So, for that we have to include some header files, so unistd, then system types.s. Then after that we have the parent process will take seconds, so here enter second, it will take the second value. Now to create the child we have to write fork function, so pid equals to fork and the pid t equals to pid. So this is the data type for that pid. If pid equals to 0, then child process created, then child process will execute. So what it will do, it will convert seconds minute, so minute equals seconds about 60, hours equals to 6 minute about 60, then it will print minutes in hours. So after that, if pid is greater than 0 or less than 0, it means child is not created, or no, it means like this is the parent process. If it's greater than 0, so it will sleep for the 10 second, then parent process will execute and it will execute its id. So now let's see the output for this program. So enter second. So I will write 3600. So it will show a minute 60 R1. Okay. Now if you wait for some time, then it will show process ID. So now in the next next question we have to write C or C++ program to create the following process hierarchy. So A will read the string, B will reverse the string, C will check the palindrome, D will uh, print all the process ID. So now let's see. So here we can see now for after 10 seconds it's showing parent process ID. So for the second experiment we'll see. So these are the header files we have to include. Afterwards we have to declare some variable. Then we are entering. Now the parent process will get the character. Now it will get the character line by line. Afterwards what we are doing, we are parent. Now the process b process id, here we are getting process b process id by get pid, and here we are creating that process b by pid equals to fork. Now here what we are doing, we are reversing the string, so we are running the loop in the reverse order. So that's here we are reversing the string. Now else, now sleep for 5 seconds, it will sleep for 5 seconds. Afterwards we are printing the parent a process id, then process c we are creating, then we are printing process c process id. Afterwards we are checking the palindrome, so same thing we are doing, we are running loop one times, then we are seeing whether the original order and reverse order are equal. If they are not equal, then it will show not palindrome, otherwise it will show palindrome. So this is this second program. So now let's see the output for this program. Okay, so now enter the word by word. So I will write like a b c b a, then afterwards I am giving quit. So for quitting we have to write e. So this is the program, so this is the reverse string. Now we'll wait for 5 minutes. Now it will show not palindrome because the reverse order and the original order it's not equal, that's why it's showing not palindrome. Now we'll see the next program. In the next program, same thing we have to do. We have to uh, create a process in this hierarchy. Then process a reads integer input, b finds the factorial of that number, C checks the Armstrong, D prints Fibonacci, E prints number of prime, and F reverses the number, and afterwards we are printing all the process IDs. So now let's see how we can do that. So first let me clear the screen. Okay, so now vi ex3.cpp. So this is the third experiment. So same thing we have to do. So here we are creating first process b. Then in the process B Here we have created process B, then process B process id we are writing. Now process B will perform factorial, so same thing, we are calling the factorial function. So at last I have given factorial function. So this is the factorial function. So this is the factorial function. It will take the number, then it will return n into factorial n minus 1, then it will find the factorial. It will return the value, then it will go up. Then afterwards it will print the factorial of that number. Now we know, uh, now we created a and b. Now b, the d is the child of b, so in the if section of b we'll create the function d. So let's see. So here we can see, in the second, in the if section of that process b we have created process d. Same thing, it will find the Fibonacci series. So we'll running the loop one time, then we are finding the Fibonacci series. Now same thing, now here we can see, now A is the parent, C is the child, and C will find the Armstrong number. So in the else part will be nothing but A parent process. So in the else part will give the if section, will create the process C. So now let's see that. So here in the else part we have created the process C, we are printing the process ID, then afterwards we are finding the Armstrong number. We are checking for the Armstrong number, whether that number is Armstrong number or not. Now afterwards that C process has two children, so in the if section we'll write, uh, we'll create the process. So process E is created here. Now we're writing the process ID, then afterwards we are seeing whether it is the prime number or not. We are checking for the prime. Now in the else part again we are creating process f and we are printing that f id, then afterwards we are reversing the number. So this was the program. So now let's see the output for this program. So dot a dot out. So enter the number. Suppose I am writing number, 5. Okay, so it will show like process b created, so it will find the factorial of that number, then parent process id, then process d process id. So 165, this is the process id, then Fibonacci series it's printing, then after it's seeing whether it's Armstrong or not. So 5 is the Armstrong number because 5 power 1 is 5. Then afterwards we are seeing process E, then we are saying yeah it's a prime number, then afterwards we are reversing the number, so 5 reverses 5. So this was the output for the 8th experiment Unix lab. So thank you for watching this video.